In this pre-lab video, we want to look at some different systems, different mixtures of different solutions, and see if they'll turn out to be buffers. So an easy way to do that is to look at the particles that are going to be present. So what if we have KNO3 and HNO3? What particles would be present? Well, KNO3 dissociates into ions. It's a soluble salt. HNO3 ionizes completely because it's a strong acid. So the question is there a Bronsted base? Is there a base that is capable of reacting with any hydrogen ions that were added? So will this happen? Because our only potential base would be nitrate. Is this going to happen? And the answer is no, it's not. No reaction, because we're not going to form a strong acid. So there are no particles to react with incoming hydrogen. And there's also no particles that will react with incoming hydroxide. We're not going to form KOH. So this is not a buffer because it has a strong acid. You see a strong acid, not going to be a buffer. Okay, what about HF and KF? Well, this is a weak acid that's going to stay mostly as HF, hydrogen fluoride, hydrofluoric acid molecules. It's a weak acid, so we'll get mostly molecules. And then we have the salt of the weak acid, the potassium, and the fluoride will dissociate. So is there anything capable of reacting with hydrogen ions? And the answer is yes. The fluoride will react with hydrogen, and therefore the hydrogen will not be able to lower the pH. So the answer is yes. Okay, so we're halfway there. Is there a particle that could react with the hydroxide? Well, hydroxide could react with the hydrofluoric acid particles, and it would form water plus fluoride. And so the answer is yes. Is this a buffer? Yes, because it's got particles that will react with hydroxide and also hydrogen ions. So anytime you see a weak acid and the salt of a weak acid, which is what we have here, we have a buffer. Now, this might look strange to you, but we've told you that these are nitrogen-based bases. They're very similar to ammonia. What we've done is simply taken off one of these hydrogens and stuck on this ethyl group, and this nitrogen can still accept a hydrogen. So these are weak bases. And then we've also provided the salt of the weak base. So this is kind of similar to if we had ammonia and ammonium chloride. All right, is there a particle that will accept a hydrogen? And the answer is, we just talked about that right here. So the answer is that yes, it will. I jumped ahead a little bit. Let's look at the particles. CH3, CH2, NH2. That's our weak base. It's kind of like if we had ammonia in there. It's an ammonia-based base. And then another particle would be CH3, CH2, NH3. But see, we have an extra hydrogen, so that's CH3 plus. It's kind of like if we had NH4 plus. And then we have chloride ions. So those are our three particles. So the particle that would react with incoming hydrogen would be that's our base, and it would form that ion. At the same time, is there something that would react with OH? The answer is yes. That's our weak acid, our conjugate acid, and it would form our weak base. So yes, it's a buffer. So you must look at the particles that are present, and I tried to pick some that are going to be a little bit of a challenge. You need to look at the particles that are present and see if there's one that will react with hydrogen ions, and there must also be one that will react with hydroxide ions.